தமிழால் இணைந்த அத்துணை நண்பர்களுக்கும் வணக்கம். நான் உங்கள் ஹக்கீம், MBBS ஸ்டூடெண்ட் இன் மெட்ராஸ் மெடிக்கல் காலேஜ். ஸோ அஸ் ஐ ப்ராமிஸ்ட் கரண்ட் எலக்ட்ரிசிட்டியோட த ஃபைனல் பார்ட் 3 வந்து பார்த்தோன்னா இப்போ நான் அப்லோட் பண்ணுறேன். அண்ட் பார்ட் 1 பார்ட் 2 பார்க்கலைன்னா மேலே இருக்கக்கூடிய ஐ பட்டனை கிளிக் பண்ணி ஃபர்ஸ்ட் பார்ட் 1 வந்து பார்த்தீங்கன்னா பாருங்க. அண்ட் இந்த கோர்சஸ் இந்த கரண்ட் எலக்ட்ரிசிட்டி சாப்டர் மாதிரி இருக்கக்கூடிய கம்ப்ளீட் ஃபிசிக்ஸ் லெக்சர்ஸ் வந்து பார்த்தீங்கன்னா என்னோட ஃப்ரெண்ட் who scored 145 in NEET Physics, currently studying in MMC with me. ஸோ அவன் டீச் பண்ண இந்த லெக்சர்ஸ் கோர்சஸ் பற்றி தெரிஞ்சுக்கணும் அப்படின்னாலும் பார்ட் 1 வீடியோவை மேலே இருக்கக்கூடிய ஐ பட்டனை கிளிக் பண்ணி வந்து பார்த்தீங்கன்னா இருக்கும் பாருங்க. அண்ட் இந்த கோர்சஸ் வந்து பார்த்தீங்கன்னா சீப்பஸ்ட் காஸ்ட்ல வந்து பார்த்தீங்கன்னா இருக்கும். நீங்கள் பர்ச்சேஸ் பண்ணணும்னு நினைச்சீங்கன்னா அதுக்கான லிங்க் வந்து பார்த்தீங்கன்னா டிஸ்கிரிப்ஷனில் இருக்கு. அதுக்கான டீடைல்ஸ் வந்து பார்ட் 1 வீடியோவில் வந்து பார்த்தீங்கன்னா இருக்கு. அண்ட் ஆல் தி பெஸ்ட் ஃபார் யுவர் ப்ரிப்பரேஷன். தேங்க்யூ.
ஸோ அடுத்த தியரி இருக்குது. ஜஸ்ட் கோ த்ரூ த தியரி. வாட் இஸ் சூப்பர் கண்டக்டிவிட்டி? See, Ohm's law is not perfect, சரியா? Remember that. This is theory. Superconducting மாதிரி சொல்லிடுறேன். Ohm's law. Ohm's law is not perfect law, சரியா? It's not a perfect law. So just go read why it's not perfect. Because we have relationship. Junction diode எல்லாரும் படிப்போம். So இது வந்து breakdown region and this is I think knee point. No, this is knee point. இதுக்கு பேர் ஏதோ ஒரு கட் ஆஃப் வோல்டேஜ் நம்ம there is some voltage here. ஸோ இது வந்து ரிவர்ஸ் பிரேக் டவுன் வோல்டேஜ். ஸோ இட்ஸ் பிரேக் டவுன். ஸோ இட்ஸ் ஆனால் ஓம்ஸ் லா இட் டெல்ஸ் லைக் திஸ். பட் யூ சி VI graph is not like this. VI graph is not like this. This is Ohm's law. But ana or diode, semiconductor diode ka. So Ohm's law is not a perfect law. So there are some imperfections. Go read about it. சரியா? Next is superconductivity. Yeah, someone told what is superconductivity? Superconductivity. At very low temperatures. Who told it? Low temperature. What happens at very low temperature? What happens? Resistance drops to 0. So there is no resistance. So when there is no resistance, what does that mean? Current. What does it mean to the current? So what happens when there is no resistance? No loss of energy. Sorry. Current will remain constant for a very long time, but there's no loss of energy. Why we are concerned about energy loss? Formula? Transformers. They transmit energy over wire. And there is heat loss, energy loss due to heat, or so there is some loss of power, I square R. There is no resistance, there is no loss of power. So a nuclear reactor length you can directly transmit. High power lines like question romba common ana question irukum. Seriya? Power. So what is that is power, but loss also is remaining same. There will be some loss because of the resistance, because there will be some reduction in magnitude of current. Over a very long distance, kudukra current constant poga because of the resistance. What does resistance mean? Flow of charges oppose pandradha resistance. Okay, we'll read that in 5th chapter, like AC chapter. Transformer power loss, idella vandu we'll read that in AC chapter. Seriya? So remember that there is always loss. So this is about superconductivity. Perisala onnum illa. Nothing much to remember and all. Next is a very famous thing, resistors in series. Formula. So in any series conduction, what is constant? Solunga. Series la what is constant? Charge. So if charge is constant, charge by time is constant, which means current is constant. So in series, current is constant. So across R1, there should be a potential V1. across R2 there should be a potential V2, and across R3 there should be a potential V3. So total potential V equal to V1 plus V2 plus V3. So V is total current I in the circuit into net resistance. If I replace these three resistance by a single resistance, so that there is the same current flows, that will be equal to I R1 plus I R2 plus I R3. Cancel out I. R equivalent will be R1 plus R2 plus R3. சரியா? So in parallel, what is constant? Yeah, potential remains constant. So in parallel circuit, when current comes, it splits I1, I2, I3. So again, potential remains constant, V across R. So how can I solve this? Net current I is going to be I1 plus I2 plus I3. So whatever current I give, இங்க வந்து I1 current வரும், இங்க I2 current வரும், இங்க I3 current வரும், so total current I. So உள்ள கொடுத்த current, whatever current flows in, current flows out. So I, what is I? It is V by R equivalent. So it is V by R1 plus V by R2 plus V by R3. So 1 by R equivalent becomes 1 by R1 plus 1 by R2 plus 1 by R3. So this is parallel. So this is series and parallel. It is reverse of capacitance. So if you remember this, you can remember that. Okay. Now the next thing is you should identify series and parallel connections. You should identify series and parallel connections. So if there are two resistances connected in parallel, what is the equivalent resistance? Or R equivalent, you can directly use this formula. சரியா? R1 R2 by R plus R2. ரொம்ப கேஸில் அது ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். This is about series and parallel. சரியா? Simple, எல்லாருக்கும் தெரியும். You just have to solve identification of series and parallel. அதை கண்டுபிடிக்கணும். சரியா? So first question. Okay. Sorry. Five, 10, 10, 10, 10. What is the net resistance? So இன்னும் clear-ஆ போடணும்னா இப்படி 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 this is the logic. 5 5 10 10 10 10. So what is the net resistance question? So this is the question. So what is the net resistance? I'll give you 5 minutes. Not 5 minutes, 2 minutes. So as I told, the logic is remain same A and B. Remember the same logic, use it. Remember this point as C. இதை வச்சு solve பண்ணுங்க. If you connect any two points in a conductor, the potentials will remain same. So A is high potential, B is low potential, and the potential difference between A and B is 10 volts. Do the question now. You're asking what is the current in the circuit. I equal to V by R equivalent. Find the equivalent resistance. That's all, because V is 10. So 10 by R. Whatever is R, that is the answer. Yeah, someone solved. So this point to say whatever this is going to be A, this is going to be A, this is going to be A. So B, P. So let us redraw the circuit. Let us redraw the circuit. So A ல என்னென்ன ரெசிஸ்டர்லாம் கனெக்ட் ஆயிருக்கு? 5 ohm, 5 ohm, ஒரு 10 ohm, இன்னொரு 10 ohm, and these two 10s are connected to C. So this point is C. So again C ல 10 ohm, 10 ohm. This is connected to B. B ல வேற என்ன கனெக்ட் ஆயிருக்கு? 5 ohm on the end, 5 ohm on the end. That's all. See how simple it becomes now. Now solve. So 10 and 10 in parallel, 5. 10 and 10 in parallel, 5. 5 and this 5 and 5 in series, 10. So 5, 10 and 5 in series. I mean parallel. 1 by 5 plus 1 by 10 plus 1 by 5. 2 plus 1 plus 2 by 10. So 10 by 5, that is 2. V equal to IR. So 10 by 2, 5 ampere. Seriya? Is it clear? Always you do this method, is going to be easy. புரிஞ்சுதா புரியலையா? Clear or not? This circuit is same as this circuit because you have marked the potential. Understood or not? It's clear or not? Yeah, okay, thank you. Okay, fine. So do series, parallel, நிறைய question பண்ணுங்க. Okay. Do a lot of questions. Okay. So try to do a lot of questions. Symmetry la question solve பண்ண பாருங்க. Try to do a lot of questions in symmetry. Okay. Do the questions, then I'll teach symmetry. Symmetry is simply by telling you the potential drop is same, so the resistance is ineffective. சரியா? நீங்கள் அப்படியே questions அப்படியே solve பண்ணிக்கிட்டே வாங்க. Like start with the easiest question, then slowly increase the difficulty, and then try to do it. There are a lot of questions in resistance. So solve பண்ணுங்க எல்லாத்தையும். Try to solve every question. Try to get the answer. Okay? We'll go to the next part. Solve. இன்னைக்கு நிறைய questions கேட்டீங்கல்ல, அந்த மாதிரி நாளைக்கும் கேளுங்க. Tomorrow also we'll have class. As tomorrow, we'll go to a new topic. Internal resistance. What is internal resistance? Can someone tell? What is internal resistance? No. What is internal resistance? The resistance offered by the battery is called internal resistance. மற்றதெல்லாம் correct. சரியா? What is a battery? A battery is normally a solution, right? ஒரு positive potential or negative potential. Normally it will be a fluid which has a positive pole and the negative electrode. Positive electrode. What is the positive electrode called? What is the negative? Positive electrode is called? Yeah, what is the positive electrode? Sure. Are you sure? No. Oh my god. Negatively charged electrode is called cathode. Positively charged electrode is called anode. Yeah. Basics. Know the basics very well. Yeah. Why? Reason. Positively charged ion is cation. Cation will move towards the cathode. So if cation moves towards the cathode, cation will move towards the negative charge only. So yeah, positive charge will be attracted by the negative charge only. So which means the positive electrode is called anode because it attracts anions. And negative electrode is called cathode because it attracts cations. Okay, know the basics very well. So there is the fluid here. This fluid will give some resistance. So whatever it is, don't bother about this. Resistance offered by the cell or the battery is called internal resistance. So yeah. So what is the relationship? So EMF will be IR plus IR. This IR is the potential. So E equal to V plus IR. This is also one of the reasons why E is greater than V. EMF is greater than the potential difference. So E minus V equal to IR. R is E minus V by I. What is V? By Ohm's law, V is IR. What is I? E minus V by I. Sorry. I will be E minus V by R into R. I is E minus V by R. So V into R will be ER minus VR. VR plus VR is ER. V into R plus R. No. Actually, it's simple. R into E minus V by V is R. That's all. Okay. Or E minus V by V into 1. What is this? This is called internal resistance. So this is called internal resistance. So EMF is V plus IR. Potential drop across the circuit plus potential drop across the cell. Current will remain the same because charge flow will remain the same. Okay, is it clear? So what happens in the open circuit? What is open circuit? Current is 0. So in an open circuit, the potential difference is the EMF. So potential difference in an open circuit is called EMF. சரியா? E. Across the terminals of the cell. Okay, so what is the relationship between EMF and resistance? So what is the thing? What is the normal relationship between them? EMF and resistance graph potana. What is the thing? E and R graph. E and R graph. EMF and resistance. How will the graph be? Is the EMF dependent on the external resistance? Can someone tell it? Is the EMF dependent on the external resistance? Yes or no? Capital R is the external resistance. So is the EMF dependent on this resistance? No. So this will get a straight line. EMF remains constant. How much ever the resistance is increased, EMF is not going to change because EMF is not dependent on the resistance. Seriya? Remember that EMF is not dependent on the external resistance. EMF could be dependent on the internal resistance, but never on the external resistance. Okay. So potential difference and resistance. How will the graph be? So this is the EMF on the value. Maximum potential difference is called the EMF. So how will the graph be? So graph is going to be. So we need to find the relationship between potential difference and R. V equal to IR, that is the relation. But what is I? E minus V by R. Correct? I is going to be E minus V by R. Or you can do this, or I is, there's one more formula for I. What is the other formula for I? So it's up to E minus V by R. Still you get the same thing. Substituting I. So further I'm just reducing. So if R is 0, what I get? If R is 0, what I get? Huh? V is equal to Do it properly and tell. No. V is gonna be 0. In the direct relationship. Why think? Why go and think here? இதுலேருந்தானே இது வந்தது. Like first into R இங்க இருக்குல்ல. Anything multiplied by 0 is 0, right? Why overthink? I just substitute பண்ணி I க்கு substitute பண்ணி after that I've just brought this relationship for the next equations. But why overthink? If R is 0, V is 0. If R is equal to R, now what will be the thing? V will be, if R is equal to R, what will be the value of V? சொல்லுங்கடா. If R is equal to R, what will be the value of V? It's going to be E by 2, right? Substitute here, E into R by 2R. So it is E by 2. If R is infinity, what will be the value of V? You can't multiply anything by infinity, so I have to substitute here. Say okay, do it until. If R is infinity or R is close to infinity, what will be the value of V? Why? Simple. R by R. No, leave it, leave everything. Just use this equation. So R by R, 1 by infinity, like anything by infinity is 0. So this term becomes 0. So V equal to E by 1 plus 0. So 1 plus 0. So it is E by 1, that is E. So on this relation, as R goes closer to infinity, V will go closer to E. Special case, E by 2. So what will be the R equal to? So remember these two graphs. With EMF and resistance, it is independent. But this graph is for potential difference and resistance. This is maximum potential difference, that is the EMF, which is only possible if the external resistance is equal to infinity. Okay? So like, remember this. The EMF is external potential drop plus internal potential drop. So everything is derived. External potential drop is the potential difference V. V equal to IR by Ohm's law. So E minus V equal to IR, R equal to E minus V by I, or I equal to E minus V by R. So V equal to IR, E minus V by, so substituting we get R equal to E minus V by V into R. I is E by R plus R. Sorry? I equal to E by R plus R. So these are all the relationships you should remember and the graphs. So on compiling everything, EMF is IR plus IR. I is EMF by R plus R. R is E minus V by V into capital. And these two graphs. So this is all you should remember. வேறு ஏதாவது தேவையா உங்களுக்கு? இல்லை. V equal to IR. So this term is invariably V. So இதை மட்டும் ஞாபகம் வச்சுக்கிட்டா போதும். These two graphs. Okay. And what is the main formula for EMF? Definition for EMF. Last class I told. This is the work done by the charge transfer. Okay. This is the amount of work done in moving a unit positive charge from the negative terminal to the positive terminal in an open circuit. We'll go for some questions. So for driving a current of 3 ampere for 5 minutes, for driving a current 3 ampere for 5 minutes, work done is 900 joules. So ஒரு சர்க்யூட்ல 3 ampere current 5 minutes ஓட வைக்க there is work done is 900 joules. What is the EMF? Yeah, can someone solve it? It's a simple question. So what is EMF formula? It is work done by charge. What is charge? So Q is IT. 3 into 5 into 60. SI unit of current is, remember that. 15, 6 and 90, it is 900 coulomb. So charge is 900 coulomb. So EMF is 900 joule by 900 coulomb, which is 1 volt. சரியா? இந்த மாதிரி question வரலாம். Next question. So I hope you can read the circuit. This is an ammeter, this is a voltmeter, this is positive charge, this is negative charge. In the circuit shown, the voltmeter reads 1.5 volts when the key is open. So voltmeter reads 1.5 volts when key is open. When the key is closed, voltmeter reads 1.35 volts. Seriya? And the ammeter reads, when the key is closed, the ammeter reads 1.5 ampere. Find the EMF, find the internal resistance. So what is the EMF? Can someone tell what is the EMF? What is the EMF? No. Hey, use logic and tell what is EMF. EMF is this value. Correct? Why? It is the potential drop. No, maximum potential order in the open circuit, whatever is the potential drop, that is going to be the EMF. Definition. Go for the definition. Yeah, go for the definition. What is EMF definition? It is the potential drop in an open circuit. So what is the potential drop in an open circuit? It is 1.5 volt. So EMF is going to be 1.5 volt. It is maximum, adanala 1.5 illa. If the resistance changes, it can still be changing. Seriya? So don't have that confusion. Open circuit, whatever is measured, that is the EMF. Now what is the R? That's all. Solve it. At least solve this. This is the formula உங்களுக்கு தெரியும். But there's one more formula. This is the basic formula. E equal to IR plus IR. This IR is as simple as that. This formula is not needed. E equal to V plus IR. 1.5 equal to, it is 1.35. Potential drop in a closed circuit, I is 1.5 correspondingly into R. So 1.5 minus 1.35, it is 0.15 equal to 1.5 R. So R is 0.1 ohm. Okay? Is it okay? Tell me, is it okay? Clear? Yeah. So don't miss out problems from internal resistance. Seriya? Simple concept. Will we stop here or will we proceed forward with the topics? என்ன இருக்குன்னா cells in series parallel இருக்கு, and then we have power. Cells in series parallel and power. Will we proceed or will we stop here? So combination of cells in series parallel, then power. அது வரைக்கும் முடிச்சிட்டோம்னா we can stop for today. Tomorrow we can go with Kirchhoff's laws. Kirchhoff's laws அப்புறம் என்ன இருக்கு? Nothing much is there. Potentiometer and the Wheatstone's bridge. So tell me, you want to proceed here or this is enough for today? இது வரைக்கும் ப்ராக்டிஸ் பண்ணிட்டு வரீங்களா நினைக்கிறேன். Now we will finish cells fully. ஏதாவது சொல்லுங்க. I'm asking, I'm giving you a choice, right? Tell something. What do you want me to do? You want me to stop here or finish cells? Unmute and tell. Someone unmute and tell. Fine, leave it. I'll proceed. No one's willing to tell. I'll proceed. So combination of cells in series and parallel. So கொஞ்சம் ஒரு மாதிரி ட்ரை டாபிக் தான். So cells in series. So first series. So this is E1 and R1, E2 and R2, E3 and R3, where E is the EMF and R is the internal resistance of the cell. Okay. So இதை வந்து I am replacing it by a single cell. So it has the so for cells in series, the net EMF will be equal to E1 plus E2 plus E3. R equivalent என்ன இருக்கும்? Can someone tell what will the R equivalent be? Can someone tell what will the R equivalent be? It is simply R1 plus R2 plus R3. Don't overthink. Because in the circuit எப்படின்னா, so 3 resistor சீரீஸில் போட்டோன்னா எப்படி இருக்கும்? That will be the R equivalent. E equivalent will be E1 plus E2 plus E3. And remember this is only valid when all are in same orientation. சரியா? அது ஞாபகம் வச்சுக்கோங்க. When all are in same orientation தான் this is valid. சரியா? Okay. Parallel. So positive and the negative terminal. By understanding only, I'm doing it like this. However you do, it's correct only. So EMF, net EMF. So அது எப்படின்னா, ஒரு செல் இருக்கும், ஒரு இன்டர்னல் ரெசிஸ்டன்ஸ் இருக்கும். ஒரு செல் இருக்கும், ஒரு இன்டர்னல் ரெசிஸ்டன்ஸ் இருக்கும். ஒரு செல் இருக்கும், ஒரு இன்டர்னல் ரெசிஸ்டன்ஸ் இருக்கும். What is the net EMF? It's going to be E1 R1, E2 R2, E3 R3, R1 plus R2 plus R3. So this is going to be the equivalent EMF. And R equivalent. What is R equivalent? 1 by R equivalent. It is 1 by R1 plus 1 by R2 plus 1 by R3. So in other terms, we can combine these two and write. How can we write? Actually, this is not correct. This is only valid for 2. E equivalent by R equivalent is remember this formula. Forget whatever I told. Okay, apply this. E equivalent by R equivalent is E1 by R1 plus E2 by R2 plus E3 by R3, and 1 by R equivalent is 1 by R1 plus 1 by R2. This is simply parallel connection. Combination of cells we'll do tomorrow. Just remember these two. அது எப்படின்னா in simple terms you are putting ஒரு குறிப்பிட்ட நம்பர் போடுவோம். This is enough. Just remember this. So seriesல it is simply add the EMF. If they are in same direction, combination just add them. So ஒருவேளை இப்படி E1 இப்படி இருக்கு, E2 இப்படி இருக்கு, E3 இப்படி இருக்குன்னா, so it is going to be, what is it going to be? EMF will only change. சரியா? It is E1 minus E2 plus E3. Why minus E2 na? I should have put it in the opposite way. சரியா? But since all are in the same orientation, E equivalent is going to be E1 plus E2 plus E3 and R equivalent is going to be series connection. Resistors la series la connect பண்ண எப்படி இருக்கும்? Parallel la E equivalent by R equivalent will be E1 by R1 plus E2 by R2 plus E3 by R3, and 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. Okay? It's clear? Clear or not clear? Someone please tell, is it clear or not clear? Okay, we can finish cells 2. Cells full முடிச்சிரோமா? Again, it's full of formulas தான். If you understand, you will know how the formulas come in. So, there are n cells in series. There are n cells in series. So, there are n cells in series. Same orientation. There are n cells in series connected across the resistance R. So, மொத்த எத்தனை செல் இருக்கு? n cells இருக்கு. So, what is the total EMF? All are equal. All the EMFs are equal. So, what is the total EMF? It is NE. ஒரு செல் இருந்தா ஒரு E, ரெண்டு செல் இருந்தா 2E, 3 cells இருந்தா 3E. Because it's in series. Seriesல என்ன சொல்லியிருக்கேன்? Seriesல I told EMF is simply added. So, E is going to be NE. சரியா? So, what is the total internal resistance? What is the total internal resistance? Someone tell, what is the total internal resistance? Again, go for the internal resistance. What is the total R equivalent? It is R1 plus R2 plus R3. It is NR. அவ்வளவுதான் முடிஞ்சு போச்சு. N times R. Series இல்ல, it is NR. What is the external resistance? R. So now how it changes is, it becomes a single battery with an EMF NE with an resistance NR and R. So what is I? V by total resistance. Correct? Because these two will be in series now. Is it clear? V by total. It is again series இருக்கும்போது NR plus R. Is it clear now? I equal to NE by NR plus R. So for special cases. So what are the special cases? If R is much greater than NR. If R is much greater than NR, what is the I? நீங்க NR neglect பண்ணிரலாம். If NR is much greater than R, what is I? நீங்க R neglect பண்ணிரலாம். சரியா? This is the current given by a single cell. சரியா? சரியா? So those are special cases, but the general formula is Ne by Nr plus R. So this is normally ஒரு cell of EMF E இருக்கும்போது, the resistance R இருக்கும்போது, what is going to be the current? It is E by R, correct? Current is going to be E by R. But here the current is N times one cell. So you get maximum current here. So this is current given by a single cell. Maximum current given by a single cell. சரியா? So this is a maximum current. As a special cases, you don't need to remember this. Just remember this. I equal to Ne by Nr plus R. So if R is much greater than Nr, Nr neglect பண்ணிக்கோங்க. If Nr is much greater than R, neglect பண்ணிக்கோங்க. Find the values. Okay? Clear ஆது வரைக்கும்? Is it clear? Can we proceed to the next part? Yeah. Super cells in parallel. There are M cells in parallel. Identical cells. இந்த மாதிரி எத்தனை cells இருக்கு? There are M cells in parallel. Each having EMF E and internal resistance R. M cells இருக்கு. And it is connected to an external circuit of resistance R. So what is the R equivalent? So it is 1 by R plus 1 by R plus 1 by R. எத்தனை times? N times. I mean M times. M cells இருக்குல்ல? So what is the net thing? So இப்போ வந்து ஒரு எக்ஸாம்பிள் தரேன். ரெண்டு ரெசிஸ்டர் இருக்கு each of R. It is 1 by R plus 1 by R. அப்போ என்ன வரும்? 2 by R. 3 இருந்தா 1 by R plus 1 by R plus 1 by R. It is 3 by R. இப்போ எத்தனை செல் இருக்கு? M cells இருக்கு. So what is the net equivalent resistance? It is M by R. So what is R equivalent? It is R by M. Because 1 by R equivalent is M by R. So R equivalent will be R by M. So what is the total resistance in the circuit? So now we have just converted everything. Sorry. R by M. And you have an external resistance R. What is the total resistance? It is R by M internal resistance plus R. So total internal resistance for parallel connection, that is in series with the external resistance. சரியா? So EMF அதாவது சர்க்யூட்டில் கனெக்ட் பண்ணும்போதும் இப்படி தான் கனெக்ட் பண்ணும். So these two are in series still. So it is R by M plus R. This is the total resistance in circuit. So parallel combination, what is the total EMF? That will be E. சரியா? Parallel combination, the total EMF will be E because they are in parallel. Why? Correct தானே? Am I wrong? Am I wrong in any way? In parallel connection, potential remains constant. The total EMF will be supplied also will be the same. You can't add it. சரியா? So what is the total current? Tanvi, formula சொல்லு total current formula. I mean, yeah. Tell the total current formula. It is net potential by net resistance. That's all. So total EMF, total resistance, total current. So take the LCM. So we get ME by MR plus R. So this is going to be the final answer. Special cases, if R, there are some special cases, just substitute it. சரியா? If R is much less than R by M in this formula, So what will be the current? What will be the current? Or in other terms, if MR is much less than R, so you can neglect MR. So you'll get ME by R. Again, if R by M is much less than R, or R is much less than MR, what you can do? You can neglect R. So it's going to be ME by MR or E by R. So the thing is like, the logic is like, when the R by M, what is R by M? R by M is the total internal resistance. So if the total internal resistance is much greater than the external resistance, connect in parallel to get maximum current. This is the total like internal resistance in parallel. Is if it is much greater than the external resistance, connect in parallel for maximum current. And the other part says if the external resistance is much greater than the internal resistance, connect in series. To get maximum current. So, upon the last part, so the thing is like, each row has n cells and there are m rows. அது ரெண்டுத்தையும் combine பண்ணி each rowல n cells இருக்கு சரியா, and there are m rows. நான் ஃபார்முலா மட்டும் தரேன். I is going to be m n e by mr plus nr. சரியா, and so if the external resistance is equal to this value, then current will be maximum. If external resistance is equal to this value, current will be maximum. Remember this. Yeah, it's a combination of both cases. So I'm done with cells also. So cells is just fully formula based. Understand, you can just do it easier. So next class we'll start with the heating effect, power, Kirchhoff's law, potentiometer and Wheatstone's bridge. That is tomorrow. Ask your doubts, do the problems. Main a series parallel. Cells, just be thorough with the basics. Basics la thorough arunga. The basic part is combination. Series la irundha E equivalent enna, parallel la irundha E equivalent will be E only. சரியா? So just be thorough with the basics. இது வரைக்கும் thorough arunga. If you remember the formulas, it's well and good. Other formulas, n cells in series, identical cells, m identical cells in parallel, and n cells in series, there are n combinations like that in parallel. It's all advantages, சரியா? But remember the basics. So this is the basics. Cells la basics வரைக்கும் thorough arunga. It's enough. Mainly the important part is series and parallel combination. That is really important. Internal resistance is important. Know all the formulas. All the formulas I've given you. E equal to IR plus IR, I equal to E by R plus R. That is like derived from this formula. And R is E minus V by V into R. And V equal to IR. This is Ohm's law. So this is everything about cells. So just learn the basics very well. And in the potential drop in an open circuit, that is EMF. All are basics. So listen to the basics very well. If you have any doubts, you can ask.